Okay, so the first one is an exponential graph. You have the range and the domain. So the range is dealing with your y's. So the range and domain. So the range has to do with your y's. The way you think about that is like y's are always vertical, so it's how far down to up, the bottom to the top. Down to up, okay? So the bottom of this graph, it goes on forever. So the bottom of this graph is negative infinity. And then the top of this graph usually stops at an asymptote. This asymptote right here is the line that it does look like it kind of crosses that, but I'm kind of curious. We might type this answer in because that does look like it crosses -2, doesn't it? But it goes up to -2. So what I'm curious about is whether it's a parentheses or a bracket, because it does look like it equals -2. But it shouldn't cross that asymptote. It's possible, but it shouldn't. So the top of this graph kind of levels out at -2. The domain is your x's. The x goes left to right. Okay, so you start with the smaller number. So the left, it goes to the left forever. And then it does not go past, looks like this point about right here. It's going to hit that x equals 3 and just go straight down, kind of like that one goes to the left. And it should be a parentheses as well.
Time out.
Yeah.
But if you look at Alex's answers, that helps you figure out the problem the way they want it. It doesn't even give you the option of brackets.
You know what? You're right. As you were talking, I noticed that. So this is interval notation. This right here is called interval notation. But this problem, as he said right there, that it doesn't even want you to do interval notation. So my bad. The answer would actually be, for the range, it would be y is less than -2. I'm scared that's going to be less than or equal to, but we'll check it in a second. And this one would be x is less than 3.
I actually think this one would be all real numbers for domain.
The domain? It shouldn't be, because it should not cross this axis right here, this asymptote.
When I did it, I like to do the same, the same thing, the same all real.
Because it doesn't level off. Like the top of it, the top
There's
of
just no actual asymptotes showing. That's the reason.
That's what they'll say? They'll say all real numbers?
Yeah.
Y'all got me all messed up here. Since there is no asymptote showing, they're saying it's not going to level off and it's going to keep going?
I think that's what they're probably saying. There is no defined actual asymptote.
All right, let's check this. So what about my y? You think it's less than, or do you think it's less than or equal to?
Try the less one.
And you think this one's all real numbers?
Yeah, right.
I mean, I guess there's no asymptote there, so how about that? All right, I guess I should have, I just assume. I guess you don't assume. You know what they say about assuming. Usually when it starts to level off like that, there's an asymptote, but I guess you're right. They don't show an asymptote, so. All right, so just to rewrite this out, this is x's left to right. Just make sure we're all on the same page. They are saying that this goes forever to the left, and they're saying this will continue down and go forever to the right as it goes, okay? On this one, the range is y's, that's down to up. We know it goes down forever, so that's easy. And then it is supposed to level out at that asymptote at -2. Okay. I'll save that picture instead. All right, next one is rewriting as logarithm and exponential. So the first one is exponential to logarithm. So you do, the way that I remember it is you call that 4 to the 0, that base 4 to the exponent 0. So it's log base 4. The exponent's up there by itself, so you put it over here by itself. and then 1. Because a log asks 4 to what power gives you 1 is what a log is asking. But the way that I remember it is the exponent's up there by itself, so it goes over there on the other side of the equal sign by itself. And then you're going the other way on this one. So here this is base 6, so log base 6. The exponent's over there by itself, and then you write what your answer is. So, and you can usually look when you transfer it to exponential, if it makes sense, then it's probably right. Like 6 to the negative 2 is 1 over 36. Okay, so whatever helps you remember that, that's kind of what helps me. Like I said, exponent's up there by itself, so I put it on the other side of the equal sign by itself. On this one, you are solving a logarithm. If you need to write it out to help you with an equation, like we were just doing, you can rewrite this as base 8 to what power is 64, okay? That's what that it's asking, is what power, 8 to what power gives me 64. So my answer here is 2, okay? So that's just if you need to write it. Once you get logarithms, you can kind of ask, okay, 3 to what power is 1 over 127? But if you need to rewrite exponential, just kind of put an x here. 3 to the x power is 1 over 27. And you say, okay, 3 cubed is 27, but how do I make it go down? Y'all can answer that. I do negative 3, right? If I had 3 to the negative 3 to make that positive, I'd put 3 cubed down here, which is 1 over 27. On the next one, you are translating it. This goes way back to transformations a couple tests ago. But all you have to think about on this one is the inside moves it left and right, but you think opposite. So that x plus 4 right there is going to move it 4 to the left. So I take that dot. There's only one spot. You just click that button and it pops that one dot up there. So I'm going to move it 4 to the left. 1, 2, 3, 4. And then that negative 2 on the outside, I move it down 2. And that should be my answer. So again, just write it out real quick. This right here, on the inside is going to go left 4. On the outside, it goes down 2. Because on the inside, you always think of opposite of what your brain wants to do. You see plus 4 and you want to go to the right, but inside's always opposite. So it's going to go to the left 4, and on the outside, it's normal. You got negative, so it goes down, positive, you go up. So then we just take this point right here, we go left 4, and then we go down 2. I'm actually not going to write negative just in case you go back and look at that. Left 4, down 2. On this one, you are using the log rules. So when you see two different logs with a plus in the middle of them, you can multiply them. So this just becomes 15. 3 times 5 is 15. You can combine them and just multiply what it is there. On subtraction, that's the opposite of addition. So you do the opposite of multiplication. You're going to divide. So 5 over 9 would log base 4 5 over 9 would be the same thing as splitting it up and doing log base 4 of 5 minus log base 4 of 9. So the minus becomes division. And then this one may be a little tricky. You look at it and see the answer, but on this one, the log rule is that you can drop the exponent down. So this 3 is an exponent. So what number to the third power gives me 8? 2. Okay, so I could rewrite log base 7 of 8 to be log base 7 of 2 to the third. Does that make sense? 2 to the third is the same thing as 8. And then once I have an exponent, I can take that and drop it down. So my answer here is just 2, What you have to realize on this problem is that this right here, this is your exponent. And then then you can go from there and say, okay, how do I make 8 with an exponent of 3? Well, 2 to the third power is 8. Okay. So once you realize that number out in front is actually an exponent, then you can kind of work backwards from there. Come on. I bet that restarted the test. On this one, you got, we are trying to expand the logarithm. So we're using those same properties that we just did on the last one. And when you see multiplication, you use addition or vice versa. Okay, so I'm doing log of y plus log of z to the 9th, but that 9 exponent, instead of writing it right there, it's going to come and drop down out in front. So the quick way to write this is just to put a 9 right here. Okay, so you put a plus because you're multiplying, and then that exponent will go down out in front. And that is that those are equal. And again, the reason you do this really is because maybe I know how to solve this part of the equation, but not the other part, and it kind of allows you to start piecing stuff together. All right, another one where we are expanding. Well, I don't know if we actually ran into this last week. Before I start expanding this one, what is the square root of x? How can I write that as an exponent? Oh, I'm going to change that to a z. Anybody remember how to change a square root to an exponent? A square root says, square root, what'd you say?
Square.
Not square. A square root is 36. That's asking, what a square root asks is what number 2 times itself is 36, okay? So the way I can write this is actually 1/2. And this says what number 2 times itself is 36. So like if you had a cube root, you could rewrite that as 1/3. Because that says what number 3 times itself is 27, okay? So you use a fraction. So I'm going to rewrite this real quick with a fraction. Can I do this? Are y'all all right with that if I make that 5 halves? 1/2 times 5? Or do y'all need to see that? Z to the 5 to the 1/2, right? It'd be easier just to write that as 5 halves. Okay, x cubed and y. That's the hardest part of this problem. That's the good news. Okay. All right, so now we start expanding it. We're going to do log of z. Instead of writing the exponent, I'm going to take it and move it down out in front of 5 halves. Now I have a division bar. And I think we stayed after and talked about this last week. But what I would do, there's kind of 2 different ways to think about it. But you have a division bar. You got 2 things on the bottom that's being divided, right? So I'm going to put a parentheses. And I do log of x cubed, but instead of writing cubed, I'm going to put it out in front. Y'all good with that step of putting it out in front? Saves you a lot of time instead of having to rewrite that, like write the whole thing twice. If you can just say, instead of writing x cubed, I'm going to put it out in front. And now it's times y, so I do log of y. Okay. Now, just because you may see this on an Alex explanation, one of the other ways they do this is they say 5 halves log z is being divided by log x cubed, and it's being divided by log y. Either of those answers work, whichever way makes more sense to you. So again, let me say that one more time. I am doing this divided by this and this, so they both get a subtraction sign. These are the same thing because couldn't I just distribute this negative through here? Okay. So either Alex should accept either answer. I'm like 99% sure it does accept either answer, but if it doesn't, like, I'd definitely give you the points for that. But you could think about that either way. Z is being divided by both of them, so they're both a negative, or you could say Z is being divided by both of them as one. All right, logarithm equation. To solve a logarithm equation, just change it to exponential. Go get the logs by itself and make sure there's only one log, and then change it to exponential. So this is base 10 to the third power equals x. So that would be 3 zeros. An exponential equation, you want to manipulate the bases so that they are the same. Okay, I need to make this, and this be the same. So how could I rewrite 36 as base 6? 6 squared is the same thing as 36, right? And then I'm going to keep that exponent in parentheses there. So all I did here was change 36 to 6 squared because now I have a 6 and a 6. So they match. If the bases match, then the exponents have to match. So you can just solve for the exponents. Just set the exponents equal to each other. So you have to manipulate it so that I have the same base on each side. So I changed 6 squared to 36. All right, so you distribute there. I'm going to subtract 4x over and get 2x, divide by 2, and I get -3. This is a test. There's only 10 questions on it, so it shouldn't take forever. You can plug that back in and check your answer. It's very easy to do with a calculator. Good, big gross number, though. What would it be? 6 to the -18? But you could plug it into both sides. 6 to the -18. But the other one was 2 times -3, -6, -9 would be 36 to the 9th. So you can, I mean, even though it's a gross decimal, you can still tell you get the same answer on both sides. And then a word problem, of course, to end it. I don't believe I chose a hard word problem for you. You got the velocity. So this exponential is, and logarithms are used a lot in real life because exponential graphs have a lot of properties to it. Finance, exponential growth, exponential decay. So science, there's a lot of different applications to it in real life. So here, suppose the velocity of a skydiver falling near a surface is given by the following exponential function, where time t is the time after diving. How many seconds after the diving will the skydiver's velocity be 38 meters per second? So we are trying to solve for t. So they are given the velocity. So we know 38 equals 55 minus 55 e to the negative 0.23 t. And we have to solve for t. This is why logarithms were invented. I guess I didn't give you the easiest word problem, but what we need to do is get this by itself. So I'm going to subtract 55 from both sides. That is negative 17. And then keep working to get this by itself. I'm going to divide by negative 55. And I have 17 over 55. We can change that to decimal in a minute. Well, okay. So now we have that e, that number e with the exponent t that we're trying to solve for by itself. What did you say? Yes. So what you're going to do is take the log of both sides, the natural log, the ln. What that is going to allow me to do, because we got to bring that t down so we can solve for it somehow. What that's going to allow me to do is take this, and just like we were doing with log properties, drop that down out in front. So now I have the ln of 17 over 55 equals negative 0.23t times the ln of e. Does anybody remember what the ln of e is? The ln of e always equals 1. That is one of the reasons we do the ln of e, to make it cancel out. So this is just going to equal 1. So that goes away, and I just need to divide by negative 0.23. So t is equal to the ln of 17 over 55 divided by negative 0.23. Sadly, I cannot exit out of my screenshot here to get my answer, but I'll show you. Let me get the answer real quick, and then I'll show you how I got it. 5 point... What'd you say?
Negative 51.05. Depends on one.
Negative 51. I think you did something wrong there because time can't be negative. I'm pretty sure that's right. I did it.
5.10.
That's what yeah. Put on my screenshot here. Just take my answer. Okay. Just to make sure, yeah, using your phone calculator is tricky on this. Does Alex have our calculator right there? Oh, the Alex calculator is here, so that'll make it easy. ln of 17 divided by 55, and then you are going to divide by negative 0.23. So when you can see it in the Alex calculator, it makes it easy. You probably got negative because on your phone, you got to make sure you close the parentheses of the ln.
I did.
You did? Okay. Oh, maybe you didn't divide by negative.
That's
0.23.
That's what my
That's what
problem
it
was.
was.
Didn't divide by,
I
you
thought it was
did.
in parentheses, but
Yeah. On your phone, it's hard. You got to make sure you close your parentheses always because, what was it? 17 divided by 55. But a lot of people forget to close the parentheses
yeah.
and then divide by negative 0.23. Yeah. See my negative. Oh, my calculator did the same thing. I hit negative, but it didn't change it. You got to hit it at the end. Okay. That'll give you the answer. But the Alex calculator, you can see it right there, so that's nice. All right. Any of the other ones that you want me to go back and do that you didn't like? How do y'all feel about that? You want to take it right now? Be done with this class?